One day on an airplane, I wondered, the structure in which I'm now sitting, in my seat, traveling kilometers, how old is it and how long it will last? Have you ever wondered about such things in an airplane? Different thoughts can come to your mind. I welcome you to the podcast about airships with your own words, which is dedicated to the project New Generation Airships. And I'm Alexander Mynko, its host. Let's begin. Today we are going to talk about service life, not of airplanes, but of our future airships. We thank Vadim Zubkevich, Deputy Head of Project Management at NOVA, Chief Designer of Airships, for this information. Let's start talking about airships again with an analogy with airplanes. Here are the modern, most mass-produced medium-range airplanes, such as Boeing 737, Airbus A320, the most mass-produced passenger aircraft. Their full service life is defined like this: as long as the resource of its airframe is not exhausted, it can function. At the same time, all other components are replaced repeatedly during operation. Each aircraft has a maintenance schedule that defines how and when all the units of that aircraft are to be maintained, what the life of those units is, and when they are to be replaced when the service life expires. Let's look at what life of 60,000 flight hours is. This is the life that is given to the airframe of the airplane. That's a lot. If an aircraft flies, say, 2,000 flight hours a year, it is considered to be operated very intensely. That's about the length of time these airplanes can be flown and operated. Let's look at what is the main service life, the main component of an airship that will allow us to say that this airship is being operated, how long can an airship be in service, and when it is already subject to decommissioning. If we take a soft airship with a soft shell, which is supported by the shape, by internal pressure, the main unit of such a soft airship is the nacelle. That is, it is on the nacelle, as required, that the license plate of this aircraft is located. The nacelle of an airship, built with the same technology as the rest of the aircraft, can also be designed for 60,000 flight hours. If the nacelle lasts 60,000 flight hours, it can last a very long time. But it will require several shell changes over the course of that aircraft's operation. This is because, after all, the shell is made of a film material fabric, which has a power textile layer. And there are additional layers: outer weatherproof layers, inner welding gas-containing layers. Modern materials with a good outer weatherproof layer make it possible to create a shell with a service life of up to 10 years. The service life of a shell is no longer calculated in flight hours. It is regulated in physical years. Even if the airship does not fly, the service life of the shell is used up. It is exposed to ultraviolet radiation and atmospheric factors. Therefore, the most promising material will be designed for 10 years of operation. Weaker materials with weaker weatherproof layers will be designed for 5 or even 7 years of operation. That is, the shell can be replaced many times during the operation of the nacelle. Even more often, cleaning or complete gas replacement will be required, because the shell is not tight enough that a single refueling with carrier gas will provide long-term operation. There are some punctures or micro damage, and just by the physical properties of the gas, it's impossible. That is, helium dissolves in the material of the plastic of the gas-containing layer, and the rest is diffusion into the environment. But this is not such a bad thing. Helium can be added from time to time, especially since the gas permeability of modern materials is very high, and these additions are very small. Much worse is that both oxygen and nitrogen of the surrounding air also penetrate the shell. So during operation, let's say, the purity of the gas decreases, and it decreases to a certain value when it becomes unprofitable to operate such an airship. That is, the lifting power of the gas is constantly falling. It can no longer be operated for the number of years declared. Therefore, purification of the gas is required. If it cannot be purified, it may be necessary to replace it altogether. The next components that will require frequent replacement are the motors and propellers. Airships, after all, are powered by piston engines. All modern aviation piston engines have a service life before overhaul of about 2,000 flight hours and allow at least 2 overhauls. That is, each engine must be overhauled twice. That is, it should be taken off the airship, disassembled, critical components replaced, gaskets, piston rings, and so on. And the engine will be decommissioned after 2 such overhauls. That means its service life is limited to 6,000 hours. Over the course of an nacelle's 60,000 flight hours, the engines will need to be changed 9 times. All of it corresponds to about the same service life of airplanes and helicopters. Let's take a helicopter propeller. It has a service life of 1.5 or 2,000 flight hours, which means that during the life of a helicopter, the propellers have to be changed quite often. The same applies to instrumentation, all equipment. So the service life of an airship can be very long if you measure it by the nacelle. But at the same time, it will be necessary to maintain it properly and replace components that have reached the end of their life, just as it is done in other flight equipment. If we move from soft airships to large airships with rigid shells, well, what is a rigid shell? A rigid shell is some kind of space structure. It used to be duralumin, now most likely it is carbon fiber that is encased in an outer shell. Inside there are compartments containing gas bags with helium carrier gas. Well, and all the other components, instrumentation, engines, propellers. In such an airship, the main element, let's say, that determines its service life will be the frame. That is, the frame of such an airship should also be designed for a very long service life, just like the design of a helicopter. Let's count on 60,000 flying hours. Now such airships do not fly, but it is possible to create an airship frame that has a service life of 60,000 flight hours, and at the same time, it has an acceptable mass with modern materials and modern design methods. This is an engineering task, but it does not require some kind of over-efforts. It requires a proper, competently structured process of design, testing, and trials. It does not go beyond the physical concepts of material properties, so a 60,000 flight-hour airframe can exist. That said, it will likely require replacement of the cladding every, let's say, 10 years, because the material won't be able to last that long. It will age due to ultraviolet radiation and other environmental factors. Helium gas bags can also last 10 years, especially since they are hidden inside the body. Then, the same, it will require its cleaning or replacement, which in a rigid airship, where there are many compartments, is much easier to do. Especially cleaning. You can pump gas from one compartment, which is dirty, let's say. You pass through a purification station and you just pump it immediately into another compartment, where there will only be clean gas. But the other components also have their own lifespan, which will be replaced as they operate, like an airplane, like any aircraft. There is nothing different there.